This is a lesson about right triangle trigonometry. Right triangle trigonometry involves a right triangle. Right triangles are triangles that have a 90-degree angle, marked by the little square in the corner. Let's review the sides and angles of a triangle. We always use capital letters to talk about angles in particular, to name them. Then we use lowercase letters to talk about the sides of the triangle. And we always say that the angle that is opposite the side, they share the same letter. So angle A has a side length of A. We use a lowercase letter for the side length, capital letters for angle measures. Then, in a right triangle, we have our hypotenuse and we have two legs. And the two legs always make up the right angle. Remember, the Pythagorean theorem helps us determine the relationship of those sides. Okay, so trig functions. SOHCAHTOA. That's the acronym that we use to remember the relationship of the trig function with the sides of the triangle. So we have the sine, spelled with an E, the cosine, and the tangent. Those are our three basic trig functions. And if you remember, the sine of A is the opposite side length over the hypotenuse of the right triangle. That's where we get the SO from SOHCAHTOA. Sine is opposite over hypotenuse. The cosine of an angle is the adjacent over the hypotenuse. And the tangent of an angle is made up of the ratio of the opposite side over the length of the adjacent side. So trig functions, their values are ratios of one side of a triangle to another. Now, sometimes we have trouble determining what is opposite and what is adjacent. So we need to talk about that. The easy thing to remember is the hypotenuse is always the side directly across from that right angle. So this is always the hypotenuse, and the hypotenuse will always be the longest side of the triangle. Now, which is opposite and adjacent depends on the angle we're talking about. So let's talk about the opposite side of an angle. Now remember what we said before. We said if we label angle A here in this corner, then its opposite side we would give a lowercase a to. So if I draw an arrow, which I have already done here, to the opposite side, then that is what we're talking about. It is the opposite of A. But if I change my reference point and I want to talk about angle B, then the opposite side of angle B is the one across from angle B. So this is the opposite side of angle B. So each side could be an opposite side. It just depends on what angle we're talking about. So the adjacent side, adjacent means next to. So the adjacent side of an angle helps to make up that angle. So let's look at angle A. So the adjacent side of A helps to make angle A. So there it is, the adjacent side of A. Just like this side over here is adjacent to B. Okay, so that could be a little bit confusing, and we will just kind of review that as we look at our trig functions and how to make up the values. So let's look at this triangle A, B, and C. And we are going to use SOHCAHTOA to find the values of each trig function for each angle. So we'll do all angle A's first, and then we will do all of angle B. We will switch our reference point. So let's look at angle A. Angle A right here. Okay, so if we want to find the sine of angle A, that would be opposite over the hypotenuse. Remember, this will always be the hypotenuse. So the sine of angle A would be 5, the opposite side, over the hypotenuse. You have to pardon our watchdog. We live in a dangerous neighborhood. Okay, so the cosine of A is the adjacent side. Remember, adjacent means the side that helps to make up angle A over the hypotenuse. So the cosine of A is 12 adjacent over hypotenuse. 12 over 13. And then the tangent of A is the ratio of the opposite side over the adjacent side. So it's the opposite side of A over the adjacent side of A. So that would be 5 over 12. Okay, now, if we change our reference point and we look at angle B, the sine of angle B is going to be opposite. So opposite over the hypotenuse. So it's going to be 12 over 13. The cosine of B is adjacent over hypotenuse. So the side adjacent to B is 5 over the hypotenuse is 13. And then the tangent of B is the opposite side over the adjacent side. So 12 over 5. So now we know what the values of our trig functions are, but we still haven't actually found the values of the angle measures, which is really what we would want to be interested in. Okay, so how does finding all those trig functions help us? Well, we can find the measures of our triangles, of the angles of our triangles, if we know the values of our trig functions. So we found the values of our trig functions just now, and now I want to know how that will help us find our angle measures. Well, we're going to use inverse functions to find our angle measures. So that'll be a little bit of a different button on our calculator. We'll have to use our calculator to find out the angle measures. So a few minutes ago we found out that the sine of our triangle ABC, the sine of angle A, was 5/13. And so now we have this inverse function that we can use, and it looks like this on the calculator. It looks like it's saying sine to the negative first power, but we don't interpret that this way with trigonometry. It's just, if we know the value of our trig function, we will use this inverse function to find the angle measure. So that'll look like this. So here's our sine function, our sine button. So if I want to use the inverse sine, if you notice the blue print above the sine button says sine to the negative first. So we'll use our second sine, and we will put in our value of 5 divided by 13, and close your parentheses just for safety, and then hit enter. And if our calculator, we should be in degree mode, that tells us that angle A measures 22.6198 blah blah blah. So we'll round that to 22.620 degrees. So we need our calculators to help us find the actual angle measure once we know those values. So we found out on our calculator that the sine of the angle of 22.62 degrees equals 5/13. And so we could find angle B pretty easy now, because we know that there are 180 degrees in a triangle, and so angle B must be 180 minus our right angle minus our angle A, and that's going to give us the measure of angle B, 67.380 degrees. Now, we went through all the trouble to find all the the trig functions of angle B. So let's see if it really works. So we did the simple calculation of subtracting from 180 to find angle B. Now let's look back at what we found angle B was. We found out by looking at our triangle that the sine of angle B was its opposite over the hypotenuse, so 12/13. And our inverse function lets us put the value of the function in here. So we hit the second inverse of 12/13, and that should equal our angle B. So here we go. Second sine of 12 divided by 13 equals 67.380 and some change. And that's exactly what we found out it should be when we subtracted everything that we knew from 180. So that verifies that the ratio of our trig functions are all consistent with all the rules that we've learned about angle measures in a triangle. So that was a lot that we covered, a lot of material we covered, and we will continue to go over that in class. But just to summarize, we've been learning about SOHCAHTOA for a couple of years now, so we're remembering again that SOHCAHTOA relates only to right triangles, and it means that the sine is the ratio of the opposite side to the hypotenuse in a triangle. The cosine is the ratio of the adjacent side to the hypotenuse, and the tangent of an angle is the opposite side over the adjacent side in a triangle. And anytime we learned about inverse functions, anytime we know the value of the ratio of the sides, we can use an inverse function to help us find what that angle measure is. So we put our value that we know from our triangle into the second sign on our calculator, and it will give us our angle measure. We will do lots more practice on this, on each part of this in class, and practice it for homework sometimes, but mostly in class. So thank you for listening. Bye.